Hey everyone! Today we're going to be discussing, we're going to be going into our introductory course to differential calculus. Today we're going to be discussing a very rudimentary concept that's a good building block for getting into derivatives and other things, but today we're going to be focusing on limits. Now limits, they describe end behaviors, and this assumes you know about how functions work, inputs, outputs, and other algebra and stuff. So let's get into it. So the way we write a limit is we write lim, and we use some variable. In this case, we're going to use x. So x, and then we put this arrow which says approaches. Now we're going to write some number. So we're going to write 1. So what this says is it's the limit as x approaches 1. In this case, from both sides. Now what does that mean? Well, let's put something to take the limit up, because this is the limit as x approaches 1. But what are we actually using the limit for? Well, let's write x over x minus 1. So this function, in this case, this is our f of x here, is what we're taking the limit of. Now, oftentimes with limits, you can simply plug in the value, and if you get an answer, great, you've taken the limit. But if your answer is undefined, then it's not necessarily, the limit isn't necessarily undefined, and you may have to do a little extra work to figure it out. So if we were to plug this in, f of 1, that would be 1 over 0, because 1 over 1 minus 1, 1 minus 1 is 0, so 1 over 0, and that is undefined. But that does not mean that the limit is undefined. So let's actually graph our function. This will be 1. So let's see what happens when this function approaches 1. So this is about what it looks like. And as you can see that there's two vertical asymptotes. Now this one goes all the way down and this one goes all the way up. But what exactly does that mean? What is the limit? Well, as I said before, the limit is describing end behaviors. So what are the end behaviors? Well, let's see. If we're talking about this as from both sides, so let's look at both sides. From this side, we see it goes across, and then it begins to rapidly decrease. And I sort in an asymptotic decrease to 1. You can see it's asymptotically starting to approach 1. It will never quite reach it, but that doesn't necessarily matter for limits. We see that end behavior is it's approaching 1. And we're supposed to asking, as x approaches 1, what happens? So, from the left side, our limit would actually be 1, but this is from both sides. So let's see what happens from the other side. Well, as this goes, you can see that it's going up infinitely as it approaches 1. The opposite. This is going to negative infinity, and this is going to infinity. Since we're talking about a consensus here from the left side and the right side, since there has to be a limit between the two, because these are different, our limit is actually undefined. These have to be the same. That's one important rule about limits. If you're going from both sides, they have to sort of have a consensus. If they're two different values, well, then there is no limit as it approaches from both sides. There's no consistency in the end behaviors. So this would be undefined, but for a different reason than what we originally thought. Now, very important thing, if I erase this, let's say we did want to do the limit as it approaches from the left, which is denoted by this little superscript here, kind of like a thing that looks like a power. Well, that would be negative infinity, as the limit as it approaches 1. From the left side, we can trace that path. We see that that goes to negative infinity. And if we do the positive, we can see that it actually approaches infinity from the right side. We can trace this path as well. We can see that that is infinity. Now, of course, you can have other values, of course, and all you have to do is simply trace the end behavior. In fact, you can see what the limit is as it approaches. You can see what the limit is as it approaches infinity, and you can get a finite answer, especially with certain types of functions. It just depends on what you're doing. But that will be our introductory course to limits. If you enjoyed, like and subscribe, hit the bell for notifications, and that will be all. I'll see you in the next video, guys.